Hello, class. This is the review questions for the coming exam logarithm based upon logarithm and exponential functions. All right, let's try to look at them together. Here, the first one. What is this in fact equal to? Now, so let's call this one as k, for example. Since I don't know what k is, we can express this one into 5 to the k power is equal to 1 over 25. Now, we know that 25 is equal to 1 over 5 squared. But the fact that we have a 1 over, that means this is equal to 5 to the negative 2 power. So therefore, k must be equal to negative 2 power, which is choice 4. Or you could have used the calculator to calculate this one. Now, in order for us to have this one solved, 16 and 64, we have to look at the common base. Either we can go for 2 or 4. For example, if I have gone for 4, then we know that 4 squared is equal to 16, and 4 to the third power is equal to 64. So we can use these two numbers to substitute in these two locations. So here we get 4 squared, so the 2x plus 3 must be equal to 4 to the third power to the x plus 2. Then 2 will distribute to both terms, so we end up getting 4 to the 4x plus 6, which is equal to 4 to the 3x plus 6. And since they have the same bases, we should have the same exponents also. That tells us that 4x plus 6 must be equal to 3x plus 6. Then of course when you subtract 6, then we get 4x is equal to 3x. When you subtract 3x, then 0 equals x equals 0. That's what we end up getting. Alright, for number 3, I want you to refer to question number 99 from PQT. You should be able to find the solution for that. Alright, how about here? So they gave us some sort of an equation right over here, where P is the population of the rabbit. We want to find out the value of T when the population is 320. So what we can do is 320 is equal to 10 times 2 to the T over 60 power. Now, then first what we can do is we cannot multiply 10 and 2, by the way, because 2 is impacted by this exponent T over 60, while 10 has only 1 as an exponent, so we cannot combine them together. What we can do is we can divide by 10 on each side. Then we end up getting 2 to the T over 60 power is equal to 32. Now, in this case, what I like to do is we can convert this one into 2 to the 5th power and then try to calculate it in that way. Or I'm just going to try to use the logarithm. I know that that's not the most effective way of doing it, but in this case, but I just wanted to share that with you a little bit. So if you have to express this one in terms of logarithm, then we get exponent, which is T over 60, must be equal to log base 2 of 32. And then you can evaluate this one using the calculator, for example. Here we get log base, so we're going to get math. Log base right over here. Base is 2, and then the value is 32, and that's equal to 5. So here we can write this one as 5. Then T over 60 is equal to 5. Then cross multiplication, T must be equal to 300. And 300 therefore becomes our answer. Alright, for number 5, I want you to refer to number 93 from PQT. Alright, let's look at number 6. The way which we can do this one is using the graphing calculator. We'll try to get this table values here. So y equals 2 to the x plus 1 and then minus 3. Now, those of you who has old font, old operating system, make sure you put the parentheses around the exponent. Now, what what I like to do is maybe I'll zoom standard will get us the nice general picture. My picture should look something like this one. Have that on our side a little bit to refer back to. But what I'm concerned about is looking at the table of values. Or maybe I'll just the table set. Making everything auto. And since the values that I like to look at has to stay within, maybe 10, 10 to 10, these values are great, but maybe okay, the 13 is a bit too much, so I'm just gonna go to here. I'll look at these values. So you can copy these values down on the side and then plot those values together. So here we get -4 and then -2 point, so we end up getting something around here. -3 will get us a little bit higher. -2 would have been -2.5. -1 would have given us -2. 0 would have given us -1. And 1 gives us 1. And 2 gives us 5. So I'll attempt to try to draw the sketch here a little bit. Actually, something like that. And we'll say this way. And that's all we had to do for this one. But just on the side note, what would be the horizontal asymptote in this case? Horizontal asymptote would have been imaginary line where the graph approaches here, which would have been -3. Y equals -3 would have been the horizontal asymptote. Number 7, I want you to look at the number 97 from the PQT, then you should have the solution to it. Number 8, I want you to look at number 91 from PQT. You should have the solution to it also. Alright, so here, the graph of the equation has an asymptote. They want us to sketch the graph here and then write the equation of this asymptote. So we'll try to do that. Clearing this one. 1/2 to the x power. Our sketch should look something like this, but the set of table of values I'm going to look at. Okay, these are the values that I'll be looking at. -3 is equal to 8. -2 is 4. -1 is 2. 0 is 1. 1 is half. 2 is a quarter. And then 3 is even smaller than the 1/8, in fact. And try to sketch this value or connect it. Maybe I'll try to do that one more time here. Okay, something like this. So here we get, that will be the y equals 1/2 to the x power. Now, and then has the horizontal asymptote, which would have been right over here. An equation of the horizontal asymptote would have been x-axis, as you can see, which is basically equal to y equal to 0. All right, so I'll post up the second part of this video soon. See you later.